It is 1:30, so it's about time to start. If everyone would please put their sets on mute, because we're hearing some background noise here and there. Thank you all. We can mute you all, but that's annoying because some of us have to unmute ourselves. Today we have a presentation by our own treasurer and board member, the other Rick Nelson, who will be showing us his spacious shop, certainly spacious compared with my little one-car garage. He's also going to be demonstrating his technique for getting vacuum chucking to work with a shop vac vacuum cleaner. So let me, without any further ado, let me spotlight Rick. There we go. And here we are.
Okay. Well, thank you very much. Again, this is I don't think it's going to be a very long presentation. My plan is to do a little walk around the shop and talk about the tools that I have. And if there's some unique thing about them that I like or don't like, I'd talk a little bit about that. And then after we get a look at that, and that won't take too long, then I'll come back and talk about some of the things that I have done. I've tried to think of things that are a little unique that I haven't seen other people do, or I've seen them on YouTube, but they aren't widely used or whatever. I don't claim any of it's really original, but I'd like to show you a few things that I found is pretty helpful. And then I'm actually going to do two quick demonstrations. One, as you may not know, I like segmented work, wood turning probably as much as anything. I probably do 75% or so of my wood turning is segmented at this point in time, although I've got a huge backlog of wood bowls and a big pepperwood slab or chunk that I've talked about earlier out there. So I still enjoy doing the regular conventional woodworking too. But the flat woodworking probably is down to about, 20% or 25% of the effort that I put into the work out here. These days, I pretty much am confined to making picture frames for flat work, although I make a lot of jigs and other things, but I haven't gotten interested in making furniture or anything like that for quite a long time. So anyway, that's kind of what it is. Welcome to my garage, and that's just what it is a garage. There's two cars parked in here all the time, except when I'm come out here, and then I usually take one of them out and work in the bay that's left that you'll see over on the other side by the lathe. So I'm going to pick up my iPad and I'll cover the camera so nobody starts to get seasick, and we'll start around on our tour. Okay. Let me switch the camera around, unplug it. Okay, I've got the little tripod here, so I will do some panning to get around the shop. Can everybody hear me, or am I coming through that way?
Just fine. Hear you just fine.
Okay. This is, again, everything I've got is pretty much on wheels. And as you look over in this corner, I've got let's see, I've got a little workmate table, and I also have, in the years past, have done quite a bit of work with metal. So I've got 2 or 3 welders around here as well. And then my sharpening system is fairly new. It's I got that from Wood Turner's Wonders, I think is the name of the company. And it's worked out pretty well. I've also bought the Kodiak sharpening system from them. And that I wouldn't do again, I don't think. It was fairly expensive. Before I had a Tormek knockoff that I used, and then I went to the CBN wheel system. but I'm still using the Tormek jigs to do the gouge sharpenings and different things. I just wasn't real happy with the Kodiak system. Although the plate that's on the right there, the tool resting plate, it works well as far as setting the degrees and, you know, doing different angles. But anyway, the other thing that I wouldn't do on that again is they talked me into, it's an 80 grit wheel, a 180 grit wheel on the left, and a 600 grit wheel on the right. And the 600 grit wheel, I just don't know what you really need that for in terms of sharpening turning tools. The ones at the school are even coarser than this. I think they're like 80 grit. So the 180 is the only real wheel I use on it, although with the platform, the tool platform on the right, I do use that for sharpening scrapers and that sort of thing. Although with 600 grit wheel, I think it's a way overkill for what I'm doing. Let's see, let's go on around here. That's pretty much a sharpening station, and then the drawers and that sort of stuff has just got junk in it, chucks and all the rest of it. Then as you go on around, my dust collector is pretty typical. It's a 1.5 horsepower jet, and that's worked pretty well. Again, with the kind of shop that I've got, I just have one hose and I just put that around from different pieces of equipment. So the table saw, for example, and the joiner and everything really has. I'm sorry?
Are you ready for lunch?
Please
Are
mute,
you ready for lunch? What do you want? You want a sandwich?
please mute
Yes.
Or do
yourself.
you want,
Yeah,
I'll have one too.
or do you want?
I think my mic must be on.
Yep, mute yourself. Thank you.
But anyway, as you go on around, the other thing that, well, there's two more things that I wanted to mention about the dust collector that I do that may be a little unique, is you notice underneath the jet bag, it goes into a 5-gallon pail with a garbage bag inside of it. And then I've got a series of clamps over the top of it to hold the ring on. It just, you know, the 5-gallon buckets that have the ring on the top that you normally see with the screw tops on, I've just got that pushed in there, and then the bags are overlapped each other. So when it is full, it isn't quite such a mess as it to empty the big bag, as you can take the clamps off and pull the black garbage bag up around the clear bag, and then the chips will drop right into it and you can just drop it into the garbage. And that really doesn't work too badly, but it's still a mess. That was a deal I got off of YouTube. And if anybody's interested in trying that out, why, I can sure put you on to the link that where I saw that being used for the first time. Then, of course, the lathe. Let's see, there was, oh, the one other thing I wanted to mention about the dust collector system is it's, you know, I'm sure we've all got those moments of, if I had only done this when I actually dreamed up and made a system like 20 years ago to use a current transformer on my tools, on the plug for my tools, to turn on a dust collector or the shop vac or whatever. And long before I ever saw one of those for sale, now you can buy them everywhere. But in my case, this is the, as I go up high there, this is a reel that I use to plug in all my tools. And then of course the metal box off to the left or whatever is where the current transformer is that goes ahead and actually does a solid state relay to start the dust collector at the same time. Then I guess, let me walk over a little closer to the lathe here. Again, it's pretty standard issue. It's much like the ones, we have several of those at the school as well. The only thing there really isn't too much to talk about there that you guys don't already know about. You'll notice the blue coil of wire behind the lathe itself. I put it here when I got this lathe 2 years ago, and I did a temporary wiring thing just because I didn't want to run 220 over here until I really knew that's where it's going to be, but it hasn't ever changed. All I did was take a regular extension cord that I got from Ace Hardware, And then I put 220 plugs on the two ends of it and ran it over here for the lathe, but it seems to be working fine. But one of these days I'll probably get 220 on this side of the shop, but I don't have it now. Let's see. I think that's probably about all there is to say about that. I made a steady rest for the bottom of it. That's really been a big improvement. I finally decided to get busy and do that when Steve Biswald had his shop demo and he was showing his steady rest. In fact, I've got a picture later on that I'll show you of this thing. The only thing is I bought the cheapest wheels I could find I think I got them from eBay. And when they came, they have those lights in them that the kids use on their roller skates and stuff. So when it's running, it's just kind of pretty in here. The lights are flashing. It really, but it works pretty well. Okay, I'm going to back up a little bit here. I pulled a table saw out from the wall, and right now it's doing what it does a lot of times, is it just acts as a table really for everything else. And that's as we get into the demo a little later, that's what I'll do, or keep my stuff on there. Okay, then a little bit on to the right, you'll notice the portable tool stand there. Now I have 3 of those on different machines in the shop, again, because they're really easy. I don't know if you've seen these or had a chance to work with them, but they make it pretty easy to roll tools around. This one is, of course, a combination belt sander and disc sander, but it sets up quite easily, and then you can roll it back and get it out of the way when you need to come back in here.
Yeah.
So that these rigid tool rest or tool miter saw stands, I guess is what you really call them. This is a pretty heavy piece of equipment for the miter saw, but it still works pretty well with it. And then next is the drill press, which it's really the only piece of equipment I've got left from my dad's shop. He was a real woodworking enthusiast too, but of course, the tools have changed pretty dramatically since his time. But I've looked at replacing that with the newer drill press. And frankly, I think this one's got features on it that I'm pretty happy with. It doesn't have variable speed. You have to change belts and all that, but it does everything I need to do. And you'll notice how rusty it is. That's because it's probably 60 or 70 years old. Okay, then I'm going to move back over this way. And I'm just going to, this is a little workbench that I made. And the way the garage is laid out, this garage was built probably in 1920 or thereabouts. And this was a little single car alcove on the back. It's way too small for any of the cars today, but this is kind of where I keep all my stuff. And the workbench you see in the foreground of my computer on it, that's also on wheels. So it just pulls out. I never move it very much, but if I needed to, I sure could. Then you can see the stands in the back. I've got a miter saw on one, and then the one on the right, the tool cart on the right, is actually a CNC carving machine. It's a number of years old. They've certainly improved them since then, but since I've been woodworking, I really don't, or since I've been wood turning, I kind of gave up on all of that stuff. So I'm not too interested in upgrading that part of it. Plus, they take an awful lot of room, and the current formats are, big tables. And then in the back there, again, I've got some metalworking tools, a chop saw. I've got a 2-cylinder air compressor as well, with a reel that extends all over, and then just a regular tool cabinet for small tools and measurement devices and that sort of thing. And then the typical stuff you come around, I've got a lot of tools and boxes down on the floor there, as I'm showing. There's another welding machine and nailer, a framing nailer, as well as a power jigsaw. And then underneath the workbench itself, you can see my old Tormek style machine and a bunch of pin nailers and that sort of thing. And then as you come around, I've got a bandsaw. That's relatively new. I really didn't have a bandsaw before I got into wood turning. but I've really come to enjoy that. That's really a pretty good machine. I've got one of the things I want to show you later is a little tool I found for the bandsaw that's really helped me a lot in terms of keeping the blade drift down. When I started, I had quite a bit of trouble with, resawing and making veneers without the blade drifting and cutting narrow and what have you. But as I say, I've got a little trick that I'd like to show you that really seems to help there. And then as you go on around, I've made a wood rack just for chunks of wood. And that really has worked pretty well too, on wheels, and pull it out as sheet goods on the back and then chunks of wood on the front. The only real problem in that is it tends to collect an awful lot of little pieces. Pretty soon you've just got to stop and clean it all out. But for whatever reason, I just never seem to want to throw anything away, and it all winds up in that cart. And then on that wall, you can see a bunch of jigs and a lot of different things that I've made. A lot of it is for the picture frames that I make, and my wedgie sleds there, and a buffing system. And I guess on this wall, as we go back around, you can see a lot of the crosscut sleds and different things that I use there. The table saw itself, it's probably 15 years old, and I really like it. It actually is, it holds a tolerance pretty well. And, if you move the fence 1/1000th or 2/1000th of an inch, you can see it on the work that you get out of it. So I think it's, for my purposes, it does everything I want it to do. But I'd sure have a saw stop if I had a choice now, just from the safety aspect of it. So anyway, I think that's the shop tour. If there's any questions immediately, the next thing I'd like to do is show you some of the little tricks and tools that I've used. But is there anything that anybody wants to look a little closer at or talk about?
And
What size is your bandsaw?
It's a 14-inch jet. It's again, nothing really special there, but it seems to be just fine for what I want to do. Oh, I didn't mention, let me get back around too. That's a combination jointer planer. And it's another tool that if I were doing it again, I wouldn't do it quite that way. The tolerances aren't good in that. It's tough to keep the fence square to the tables. Again, it's the old rule, you just didn't spend enough money on it. But it still works. I only really use it when I'm doing flat woodworking. A lot of people use it to prepare their work for segmented work, but I do that a little bit differently, and I'll talk about that in a few minutes.
do you have a
had
fire?
enough- What?
Do you have a fire extinguisher in your shop?
I've got one in my tool room around the corner that it probably should be out here, but I have one in there.
I noticed in that alcove thing, you had a whole bank of electrical, some things pushed, plugged into them. What was that all about?
Well, that's, as I'm sure all of you guys are as well, I think that's what you're talking about, that wall of switches. I'm on a big lot here in Walnut Creek. I've got over an acre, and it's pretty well all landscaped. So I've got like 24 sprinkler stations.
Sprinkler.
And that's my control system that puts the 24-volt out to the sprinkler system. And it's all controlled off of this Excel spreadsheet to a controller, essentially. And then those controllers are the ones that are plugged into the wall there. And then they, as I say, a controller and a transformer for each one of the stations.
But you had a whole bunch of chargers for all your power tools. I think, wow.
Yeah, no, that'd be more power tools than I have for sure. Any other questions or things you'd like to hear about? Okay, well, let me, Rick, if you could switch me back over to the laptop then. I'm going to have to, again, this is a process of
Let me find you.
Rick, can you put me on to the
I am
laptop? Oh,
looking for you at the moment.
Near the
Okay.
bottom.
There you are. Gotcha. Da, 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 da. Okay,
Well, I see you.
you have your video on?
That's probably the problem.
There you are.
Okay. Sounds good. I'm not. Okay. So the next thing I'd like to do is go through a few little tips and tricks that I've used. I'm still only seeing you, Rick. Has everyone else got the right? Yeah, I guess you do. I see on the iPad that I'm up there. Okay. So let me start here by sharing the screen with you, if I'm okay to do that.
Should be.
Yeah, looks like it's good.
You want a pin, Rick?
Yeah, he's pinned.
Okay, and this is, the stuff I show you from the computer is just going to be a series of photographs. But this one is, the same pictures you just saw live, but I actually showed you this before, but this is the current transformers that I, set up to turn on my vacuum cleaner on and off. Anything that's plugged into this reel switches the vacuum on and off. I do have the control over behind the dust collector, so I can turn the dust collector on without something else triggering it, or I can turn it off so it doesn't run when a particular tool is plugged in there. And again, in part of the demo, I'll actually make some of that work. And I'll pass through this one. This one is my steady rest with the blue lights flashing. But certainly one of the things that I've made a lot of use of are the Beal taps to make face plates and glue blocks. And so I just wanted to mention that. Again, that seems to be a pretty effective deal. I still use the metal face plates on almost everything I turn as far as that goes, but the jigs and the face plates and all the rest of it, it's a pretty simple deal, and it's sure a lot cheaper than buying a faceplate every time you want to do something. Another thing that I've found that works really well is this is a Duragrit sanding block, and this one's 120. You can get them in all kinds of different grits, but particularly for the segmented work I do, it's really handy. You don't have to have a sandpaper wrapped on a block, and it's silicon carbide is what the aggregate or the abrasive is on it. So there's, it just never wears out, and you can sit here and sand your segments or whatever else you want at 120 grit, and it's nice and flat. You don't have to really fool around much at all. So that's been a thing that I've thought was a pretty good trick. This is the bandsaw companion that I talked to you about that I started using.
Hey, Rick,
go ahead.
Jerry here, a quick question. Going back to your Duragrit, what are the dimensions on that? It's hard for me to see in the picture there.
Oh, okay. Well, let me, I'm looking at it here right now. It's about 2 inches wide and 5 inches long.
Okay, thank you.
Something like that, but it's just the right size for your hand, basically. Okay.
Where did you get it at?
Well, if you do a Google search for Duragrit, they'll come up with it. They make they make a series of pads for the oscillating sander, a hand sander and that sort of thing. They're all the silicon carbide.
Okay, thank you.
Grit. You bet. Again, the bandsaw companion, this is not much money. It was like 25, 30 bucks. But the two little, if you look right here, those are rare earth magnets, and then there's a little slot next to it. So what you do is, again, they say it's 3-in-1. It does things like being a compass and all of the rest of it. But what it really does best is if you put it on your blade, as I've got it right there, it attaches to it magnetically, and it, once you've got your bandsaw centered on the wheels the way that you want it to and whatever, you bring up your fence and adjust the fence so it's parallel to the blade. And boy, does that make a big difference in terms of getting rid of the drift in the blade. So again, that's something that I don't know if you're interested in, but again, you could Google bandsaw companion and it comes back with that, but it's a pretty good little deal.
So Rick, what prevents the, so I mean, you take that, you just use that to set your fence and then you remove that. And then, so when you start cutting, what's to prevent the drift?
Well, it's the blade is aligned with the fence, and that takes the drift out of it as far as my experience goes. Now, again, I'm not a real authority on bandsaws, but you know, the question has always been how to tune your saw so where you don't have you know, the blade wandering through it. And before I had that, I've used it quite a bit to cut stock down or resaw stock to half size to make smaller rings, segment rings, and that sort of thing with it. And it was a real struggle. It tends to walk away from the fence either on the leading edge or the trailing edge. And pretty soon you've got a wowie in the cut that you've made that's only a 1/16 of an inch, but to get that out, you've got to take a lot of wood off or do a lot of work on the joiner as well. So anyway, that's one thing that I think is worth noting. The other thing is the cold jaws. You know, I don't have a drum sander, but again, for the segmented work that I do, that's how I flatten my rings. And the first thing I'm going to do on the lathe is show you how I go about that. But it works pretty slick. It takes a little longer probably than doing it any other way. But as Jim said in the segmenting class when I first got into it, is the real trick is to figure out how to flatten the first side of the segment, a segmented ring. After that, why they go pretty quickly. But anyway, what I'm doing now is doing the first side with the cold smaller rings. And then I have well, and here it is on the lathe with the cold jaws. You'll notice I've got a spacer behind them. I don't always use that, but the advantage there is then I can cut the ring into two, so I can split the ring at the same time.
Oh, cool.
So that's the way I do that. But for big rings, this disc is 18 inches in diameter, which is just the size of my lathe. But I put the big rings on this thing and then use hot glue to hold them on there. I use 4 patches of hot glue and turn the ring square on it and then flip it around with the tailstock and put it on the stack of rings that I'm building for big pieces. Again, you can see it's pretty well torn up, but that doesn't seem to affect it all. You know, it keeps tearing the veneer off the plywood, but it really doesn't matter. I just use hot glue and I don't know if I'm pushing the envelope with it a lot, but I use 4 pieces about 1 inch long. So in 4 places equidistant around the circumference of the ring, I just put about 1 inch of hot glue on there and then use a wood chisel and a mallet to pop it off when I'm done. And it works fine. As I say, it doesn't look real pretty, but it sure works. The other little trick I'll mention just kind of along the way is you'll notice the perpendicular lines. That works really well if you're making segments that are, you know, 12, 16, 20, 24. But if you try an 18 segment ring on it, why it doesn't come out right. So you can't really line up the joints on those 4 things. But by lining up the glue joints on the 4 lines, you can get it pretty close to centered. But then I do use a combination square adjusted to the difference between the ring diameter and the plate diameter as I go around it, just to make sure that it's absolutely centered as best I can get it before I start to turn on it. Turning doesn't really matter if it's off center a little bit, but when you turn it around, put that on the tailstock and bring it up against your stack of other segments, you want it to be as true as you can get it. So that's why I go through that trouble to do that. The other thing, then, and I'll show you this, is you know, the sanding stick. After you machine the face of a segment ring, the procedure is to sand it flat to make sure that you're absolutely dead flat as you go across the segments. And most people use a board with a piece of sandpaper across it and rest it on their tool rest. But what I do is this is a 10-inch disc of MDF, and I just use the self-adhesive sanding discs on it. They're real cheap, they're real easy to change. And you know, with the sanding stick, it was always a mess to try and get those things on there. So I've I'll show you how I do that. On the back of it's got a recessed on it that I can put in a 2-inch chuck. About the only thing I ever do on the lathe with this thing is hold a crepe stick up against it to try and clean it off. But I have used it as a disc sander, but it's just a little too messy for me. It throws a lot of dust around that doesn't seem to get caught. But it just the ticket for sanding segments, and I'll show you that. The other thing that I've done is I have an air compressor, and you've seen that, and I use that for quite a long time with, to just blow dust around and whatever. But then I had this reasonably cheap paint sprayer that I've used for painting a lot, and different kinds of finishes. But it came with a nozzle to it that, and suggested that you could use it as an air gun. And truthfully, it's as good as it really works as an air gun, better than the compressor stuff does. So that's what I use around the lathe if I'm going to blow dust around, or hollow forms, you're going to blow the chips out. This thing works really well, and you don't have that compressor running all the time. So that's another thing that I think has worked out pretty well. Okay, so I think this of course is where we're heading with the shop vac demo. This shop vac demo is something that Claudia talked me into 2 years ago, and COVID saved me for a year. But I guess today is the day we're going to talk a little bit more about that.
Always got to pay your dues.
Yeah, somewhere or another, your past always catches up to you. That's right. But anyway, as we go through this, I'll show you more about it. And then my plan would be to do a demonstration of both the flattening of the rings and then a shop vac chucking system. And then come back and we'll talk a little bit about the theory and what makes this thing work at all and where its weaknesses are, and the traditional vacuum chuck systems, where they're different and why they work better in most cases than this thing does. But anyway, we'll get through all of that as sort of it's important, because if you decide that you want to give this a try, you really need to understand what its limitations are. It's just not as powerful a vacuum as a vacuum pump would be. So you kind of got to think a little bit about what you're going to do with it, and when you're going to give up and say, no, that isn't going to be worth the effort. So the two things that you need to make this work is a spindle adapter. That's what I'm going to call it. But it's just a piece of wood here that hooks. Now, this is a little hard to get the perspective, but you're looking at the big end of it right down the bore. And the chuck goes right in here, and it rides against this lip in here. The hand wheel, sorry. The hand wheel rides right against this. And then, of course, on the other side of it is the hose goes over a tapered fitting there. So that's really all. And we'll talk about all of this stuff and what the significance of leaks and how tight it should be and all of that stuff as we get along with it. Again, most lathes, as you saw, mine is a jet lathe, and it's got that goofy hand wheel on the back that's just a cylinder. So that's what this is built for. Now, the truth is you could actually use you don't really need that with my lathe. The hose actually will fit right over the hand wheel, and you really don't even need a spindle adapter for it. The leakage isn't significant enough to cause a problem. And I don't do it that way because there's less leakage when you build something with, or when this adapter comes up tight against the end of the hand wheel. And the other thing is I don't want to wear out the hose with the hand wheel running inside of it. So I've made this little adapter. The lathe that I had before I got the jet had a more traditional hand wheel, like a Powermatic, or it was a Rikon lathe, in fact. But I used the same system with it, and you can see it's just a different shape. So it fits over, it's a little cup that fits over the hand wheel. And then on the back side, if you could see it, the hose just slips into the hole that goes through there. And the other thing you need is a faceplate. And again, this is, I've got several of them. This one's about 12 inches, I guess, in diameter. I've got one that's a full 18 inches in diameter for big pieces, but this thing works for most of the stuff that I do. What it is again, it's just, again, an MDF blank that's been turned round on the lathe. On the back side of it, you'll see, get to it, where I've used the Beal tap again to thread this faceplate on the back and then glue the glue block on the MDF. And then I just, you know, this stuff is just shelf liner. It's a rubberized foam shelf liner that comes, I got it from Ace Hardware. There's probably other things that would work just as well or maybe even better. But this is thin enough that when it, the vacuum compresses the bowl onto the faceplate, it's solid. It's not spongy at all. So it's thin enough that it really does rock down tight. But it's pliable enough that it makes a, you know, it digs in there and makes a real firm seal with the faceplate. So anyway, that's the sum total of all of this is those are the only pieces you need. And that, of course, gives you the, you know, one of the big advantages of doing something like this is it's just dead simple to set up. It's dead simple to use. The stuff you need to make, it'll probably cost you $10. And it, you know, in the right application, it works very well, actually. So anyway, we'll get on to that as we go. So I guess, Rick, well, first of all, anybody want to stop me and go back and talk about anything or expand on anything?
I have a question.
Yeah,
Sorry,
please.
this is Jim. I got a question. On the outboard fitting where the shop vac hose goes into that wood fitting, someplace there has to be a rotating joint, and I don't quite understand that.
No, there isn't. This piece of wood just rides on top of that hand wheel. There's no joint in it. The seal is inside. Again, if you look in here, you can see where it's all dark and marked up. I've used wax on the back of the hand wheel or whatever to lubricate it a little bit so it doesn't chatter and it runs pretty smooth. But that is the seal right there where the wood goes against the hand wheel.
So it's designed to slip against the end of the hand wheel.
Exactly. That's exactly
Thanks.
what it
I got
is.
it.
Yeah.
How do you determine how much pressure you have on your vacuum?
Yeah, I'm going to, you know, when we get done doing the demo, I'm going to go into that pretty extensively. Anything else? Again, Claudia, thank you. Thank you very much, Claudia, for today. I appreciate it.
It doesn't leak around the fitting where it's spinning inside there?
It does, yeah. And you don't want to make it too tight. The last thing you want to do is have this thing bound up. But I will show you later and I will convince you positively that that leakage doesn't matter. Okay. Anyone else? You will be amazed. Okay, so could we go back to the iPad now?
Yeah, why don't you unshare your screen?
Okay, that I can do.
Yeah, okay. And I will find the iPad and get you back on that. Here we are.
Okay, can you hear me now?
Yep, just fine.
Okay, let me get now, what I'm gonna do here is I'm gonna actually move the iPad over where that door is. I'm gonna open the door and then I'll set up the tripod in that door and that'll shoot backwards so you can see the headstock on the lathe. So hold on just a minute and I'll get that done. In terms of shop tours, this is certainly one of the more modest shops that you've seen on this tour circuit. And as I say, I have desires to build a big shop someday with lots of new tools, but it probably isn't ever going to happen. Where I live in Walnut Creek, there's a 20-foot setback rule. And that's just hard to get around when you start building stuff that your wife approves. That winds up putting a shop right in the middle of your front yard. Why she isn't real happy about that. So it just isn't going to happen. Okay, Can everybody see what I'm doing here?
We see your lathe and your dust collector.
Good, that's perfect. That's what I want to do. Well, as you can see, I've got a segmented ring glued up here, and it's in the coals jaws. So the first thing I'm going to do is just go through the exercise of flattening and sanding that real quick, and it just shouldn't take a minute. The business of flattening rings on the lathe and then using a sanding block to make sure that they're true. After you've done that about 1,000 times, it gets to be pretty straightforward. So anyway, let me get my face shield on. Now, I don't know, can you hear me now? Has the sound quality gone down that I've got a face shield on, or can you still hear?
We can hear you pretty well.
Okay, well, there's not a lot to talk about. I'm just, you know, one of my other failings in life is I use a bowl gouge for almost everything. And this is certainly another place that I do. It really is just a question of riding the bevel, just like it is with almost everything. And then I'll do just a scrape on the front of it to kind of get the lines out of it. Check to see that it's good order, and it is. So then I'll sand it, and the reason I kind of wanted to do this is I did want to show you how I use the sanding disc to, as a sanding stick. So I'm going to turn on the dust collector, and that may change the audio, so I won't do any talking while I'm doing this. But
Rick, I got a question.
yes.
So what is the advantage of using the disc over a sanding block or a sanding stick?
There, in terms of function, I don't think there is any advantage, Jerry. It's just a lot easier to, buy those round 10-inch discs and slap them on. They're self-adhesive discs, and to slap them on a disc like that, for me, than it was to maintain the sandpaper on a board.
Yes, or I got it. Yes, and I agree. I agree with that because when I use a sanding stick, and you're right, it's a pain in the neck to just pull off the old sandpaper and put it on the new one. And so so that would be much easier. Thank you.
Yeah, that's really the only advantage I can see to that. But anyway, then to quote Jim again, is I've got the first side of the ring trued, and so from there on, once it's glued onto the stack, then you can switch it around and the other side measured. But it goes pretty quick. As I say, for a long time I was trying to figure out what I could get rid of in here and get a drum sander in here. But again, it's like other things. I've kind of decided I'm happy doing what I'm doing. Okay, any other thoughts before we go on? Okay. Again, this is the faceplate that I'll use for the vacuum chucking. And again, I don't know if you can see this or not very well, but the foam that's on the top of it, it's been chewed up a little bit over time, but it's it still seems to work quite well. But anyway, that's that. You need to get the hose.
So Rick, a question. So is that faceplate actually threaded?
Yes, that's the back of it. I threaded it with a Beal tap, so it just threads right on the spindle. So, you know, if that makes sense.
Yep, got it.
Okay. I should have probably had this plugged in and ready to go before now, but here you go. I'm just plugging it into my cord wheel. And I'll turn this off so the dust collector doesn't come on when it does. Now, again, I'll turn the shop vac on now, but if you can see this has got the adapter on it, and it just slips over the end of the lathe or the hand wheel. Actually, let me get the bowl and get it close to it first. This is a walnut bowl that I just finished up here a day or so ago for this demonstration. It actually has got some pretty good figure in it, so I hope I don't screw it up. But the way you mount this is just like you would with really basically any chuck. But one of the other tricks I do here is slow the lathe down a little bit to make sure it doesn't take off on me. But I'm going to turn the lathe on pretty slowly. And then I'm going to advance the tailstock to get the bowl as centered as it can. And then tighten up the tailstock here. It's just got a cone center on it. Again, this faceplate without being vacuum chuck at all makes a pretty fair jam chuck just by itself. In fact, by tightening this up a little bit more, you could probably, you know, it works as a jam chuck just as well as it would with a vacuum chuck. But the next thing I'm going to do is I'm going to turn the shop back on and just put the spindle adapter over the hand wheel. And then what's going to happen is you'll see that it'll suck it into the rubber to the point that the cone stops turning. And what I'll do then is I'm going to tighten up the cone, because why not have all the support you can get for as long as you can get it. And then I'll start working the tenon down with a bowl gouge again. But when we get done, get in as far as you can with it, then we'll pull the tailstock back and we'll finish it with just with the vacuum chuck part of it. So anyway, any questions before I turn on the noise?
Go for it.
Okay. I don't know if you can see it, but the cone center has stopped turning now because the chuck is pulled in. You know, the bowl is pulled into the chuck away from the vacuum right now. But there's no reason to leave it like that to start with. We might as well use the cone center. Now, can you hear me at all through this, or should I
Yes.
just stop talking?
We can hear you.
Okay. Okay. I'll turn the speed up a little bit. It's at 150 now. And I'll turn it up to probably 400. That's enough. Now, we'll talk more about this after I get done with this. But of course, one of the things that's really important here is there's a way to use the tool to cut into this that puts the pressure into the faceplate. That's what you want to do. If you start going across it like this, it's going to peel it off there a lot quicker than if you just make cuts where you actually put the pressure back towards the faceplate. Actually, I'm gonna have to stop and get a little longer tool rest. This one isn't long enough to reach in there very well.
Rick, you might want to comment on the fact that you're using spacer rings on the bottom of your tool rests to set the height properly.
I'm using what, Jim?
You have these little spacer rings that you put on the bottom of the tool rest shaft.
Oh,
So when
yeah,
it drops
yeah,
down
yeah.
in there, it always lands at the right height.
Yeah, that is a trick that I learned from the guy that was up in Napa that did a demo for us one time. He was talking about that. And I picked that up from that demonstration. I thought to myself, that's a pretty good idea. And it works really well, except when you got to go below center for some reason, then you got to take them off. Okay. The trick here, I think, is, I'll mention it again later, but, you really need to think about your tool every time you come close to the wood. If you just jam your tool in there, you're going to get a catch and it'll be all over. So don't do that. And again, make sure that you make your cuts where they keep the pressure towards the faceplate. Keep as much pressure off of that steel as you can. Okay, that's about it. So now I'm going to pull the tail stop back out. And I'm not going to really finish this because it's kind of like watching paint dry from your end. But again, it's just the traditional cut you make. Okay, I'm going to, well, I'll finish a little bit more of it because I want to set it on ground. Speed it up a little bit. I'm up to about 600 now. Now, just one more, I'm going to do one more thing. I'm going to put a center in there to make sure I can put it back on the lathe to finish this up. Now I'll carry the camera back over here and show you the end of it again. But you see, Jim, this it just rides on there, and it's on there pretty good. But of course, when you take it off, the bowl's going to drop. And there you go. So
Rick, you have to get past those two leg screws on the hand wheel. There's two little set screws in there that holds that on.
no, in fact, let me show you how that works. This is actually this is the sealing surface right here. The cone just sort of centers it on top of this, but as far as the adapter piece, it just slides in there and it seals on a shoulder that's in there. So, you know, that's it. You're getting quite a bit of leakage around inside of this thing. And as I say, the next thing I want to talk about a little bit is what that really means.
Right.
How much leakage you can tolerate. But anyway, it's not a tight feel. It is reasonably tight, but it's not, you know, tight like a seal bearing that you'd use on a traditional vacuum chuck. Okay, anything else here before we go back over to look at some more pictures? Okay, let's
Rick, what kind of wood is the adapter made from? It would have to be kind of a hardwood, wouldn't it?
I think you're muted, Rick.
No, it's not. It's nothing special. It's two pieces of 2x4, dug for 2x4, glued together and then turned.
Okay.
That's what this is. I don't think it matters whether it's hardwood or softwood. It just doesn't matter. Okay. Could you spotlight the other camera, Rick?
I did. Your laptop is spotlighted.
Okay, can you hear me again? Is everybody here with me?
Yep. Loud
Okay,
and clear.
yeah. No, I was saying this is a Doug fir thing. It's nothing special whatsoever. I do put a little wax when I first built it on the hand wheel to rub on the inside, and that's why it's black. But it made it so it doesn't shatter quite as much. But it's just, that's pretty trivial. I don't think it really matters. Okay. Well, if there's nothing else, let's go to my slideshow again, and I'll share the screen. I think this is where we left off. Can everybody see that?
Yep.
Okay. So this is where we started and ended with the turning. The first thing I want to do is show you, you know, not that you all haven't seen this before 100 times, but this is a traditional vacuum chucking system. And, you know, this is you know, there's no doubt about it. This is a superior system to what I've shown you today. It has some decided advantages, one particularly, but there's some things about it that don't work quite as well as chucking them the way that I do. One of them, of course, is this is about at Rockler. It's between $200 and $300, and you know I've seen them on sale for like 100, 150. But I don't know. I enjoy kind of making stuff that works without buying stuff, and that's one of the reasons I did it. The other thing is just something else to go wrong, something else to worry about where you put it and how you take care of it. But there's no doubt about it. This has got the power to do an awful lot of things that the shop vac you shouldn't even try. but in essence, it's a positive displacement vacuum pump. And can you see my cursor wandering around here? Probably.
Yes.
It's got a vacuum gauge that reaches inches of mercury and a bleed valve here, and then it goes to a swivel seal to seal the, all of this has to be very tightly sealed. And then typically I haven't a lot of experience with this kind of chuck, but these barrel chucks that you put on the end of them seem to be the way that most of them are used. And that'll be a significant difference. I think you could, well, I know you could use a faceplate just like I just did, but typically they start out with the barrel chuck. And what I want to show now are just a couple of charts that really point out the differences between using a shop vac for a chuck and a traditional vacuum chuck. Now on this graph, now again, there's not going to be a test and this isn't going to get really technical, but I think at least for the engineer in me, this explains what's going on and what the differences are between the systems as well as anything I could come up with. On the axis here that goes up and down, the vertical axis, this is the vacuum. Now the scale I've chosen is inches of water column, WC water column. Typically on the commercial units, they'll have a gauge that shows inches of mercury. Well, the conversion between water column and mercury is about 13.7. So if I've got 137 inches of water column, that's 10 inches of mercury. So, and 250 is roughly 20 inches of mercury. And then when you get up to 400 inches of water column vacuum, that's a perfect vacuum. And there aren't, none of the vacuum chucks are ever going to approach that. In terms of operation, somebody can help me with what I don't know about these things. But I think around 20 inches of mercury is kind of where that'd be kind of the top of the range. But if you go back and look, you can adjust that vacuum by this bleed valve that's on the end. And what you're doing is you're just adding a little bit of air to it or bleed to it. And the performance of this vacuum pump goes down here to the one that I showed you here on the other deal is 3.5 cubic feet per minute. At 3.5 cubic feet per minute, it produces no vacuum at all. But at 0 cubic feet per minute of air through it, it'll theoretically come to a perfect vacuum. It won't, of course, but it'll probably settle in here between 250 and 300 inches of mercury. But then as you allow bleed air to get into it, it just, the air, as you move from left to right on this scale, you just walk right down this vacuum curve and you lose vacuum all the way down as you lose bleed air, as you use bleed air into it. And you do that with a valve, but you also do that with any leaks that you have. So in the bowl, if there's cracks or if it isn't sealed well or whatever, leaks are the bane of this system. If it wasn't for the problem of controlling leaks, there'd be no, I mean, it would be a perfect system. But anyway, if you have a leak or if you have a crack in your bowl or whatever it might be, you're going to wind up very quickly running out of power with this thing. But as long as it's tight, you get an awful lot of vacuum. Now the shop vac, I'll show you how I measured these curves. Somebody asked about that earlier, but this is a performance curve for a centrifugal compressor, which, you know, they're blowers, fans, whatever they are, whatever, they go by a lot of different names, but they work on the principle of centrifugal force. So they essentially throw the air out of the machine. And if it weren't for friction, this would be a flat line all the way across. It would never fall off. It does fall off because there's friction, you know, as the air moves through the system, and in the shop vac, it through a filter, it does different things. But you can see that's the curve just gradually falls out. But here you're out at 100 cubic feet per minute versus 3 for the vacuum pump system. So the shop vac system strength is that it pulls so much volume. And I'll get to the next slide and try and make this point. This is the same curve we were just looking at. This orange curve here is the orange curve that's on this one. Now, so again, in my particular vacuum system, if it's completely deadheaded on the shop vac, I get 47 inches of draft or vacuum. And as you start to get more and more air through the system, you get more and more friction. So the vacuum starts to drop off. But I mean, you're getting out here to 50 or 60, 70, 80 cubic feet per minute before you actually run out of gas. Again, keep in mind that the traditional vacuum system runs out of vacuum at 3.5, which is way down here. So there's 2 points that I want to make here. Is one, we talked about the leaks around the inlet to the spindle, for example, with a little adapter. You'll notice that you can get an awful lot of leakage, like 20 or 30% of the total flow that you're going to put through the shop vac, and the pressure doesn't fall off very far. So that's what I tell you, that the leaks don't really matter. The business with my little wooden spindle cover that goes on there, the fact that it's got a lot of leakage around it, you do the best job you can of trying to make a tight seal back there. And the same thing on the faceplate. You do the best job you can of trying to make sure that the bowl sinks into the faceplate and there isn't a lot of leakage around the headstock screws and that sort of thing. But truthfully, it doesn't matter. In my case, the system you just saw, I've measured the pressure at the headstock or at the bowl. I had a little bowl and I put a hole into it and then measured the pressure there. And it's exactly 47 inches, just like the shop vac is on its own. So there isn't enough linkage there to affect the vacuum at all. So that's one of the strengths of this thing, is it does. Now, the other thing that I worried a little bit about and looked into, and then it makes a lot of sense, is this curve, the blue one, is a shop vac with no filter in it at all. And the orange curve is a shop vac with the dirty filter in it. And it wasn't filthy dirty, but it was pretty well clogged up. But again, we're working up in this range right here. It doesn't matter. So clean filter, dirty filter, whatever, the shop vac's going to give you this much vacuum, and it really doesn't matter whether the filter's clean or the filter's dirty, or whether you've got leaks or whether you don't. It's still going to be right in this range, a very tight range of vacuum that it's going to supply. It's a volume machine, and it's going to put out the same vacuum at virtually any volume until you start really moving some air through it, and then the friction takes over and it'll start to drop off.
Rick, a question.
Sure.
On the shop vac, when it has no hooks to it, what's the maximum CFM you expect?
Well, I looked at the shop vac as a system, so it's the shop vac and the hose, the black hose, but that's
Correct.
Okay, so that system, wide open, this last point with no filter. Can you see me over here where I'm pointing?
Yep.
That's the last point on the curve. So it was wide open, all the air could move with no filter in it through the hose. It came down to what, 110 cubic feet per minute. The other thing I want to just point out, or it's kind of slipped by my mind, but mine is 47 inches is what it measures in terms of how much vacuum it produces. I think that's on the low side. I've tried to research that a little bit, and I think more typical is 60 or 70 inches of water column is what typical shop vacs do. My shop vac is, a $100 unit from Lowe's or whatever. It isn't ever supposed to be the top of the line shop vac, but if you want more vacuum out of or if you think your shop vac may have more vacuum than mine does, but 47 is where it came out.
Comment?
Hey, Rick.
Oh,
yep.
Are you concerned about your hose collapsing?
No, 47 inches of water column isn't enough draft to worry about any of that. With a vacuum pump system where you can get 10 times that much vacuum, you start to worry about hoses. You start to worry about your bowl being destroyed. I mean, it can crush it like stepping on a bug. The shop vac just doesn't have the power to do that. If you go back and look at it, you're up in this range for vacuum with those machines, and down here, you're just not even close. Any other questions?
yeah. Can you hear me?
Yep.
Okay, so, you know, if you have a vacuum pump, those are designed to run against a vacuum,
Right.
it,
Yep.
it's just meant to run that way. Whereas if you have a shop vac and you plug the end of the hose, you can hear it working really hard,
No,
and
that's backwards, Peter.
Huh?
That's backwards. The reason you hear the change in tone for the shop vac when you plug it up is because the load's gone. It's essentially the motor is freewheeling at that point in time. That's why the pitch comes up.
okay. That I didn't realize, but the comment I was actually going to make that kind of goes along with that is that a lot of times they use that airflow to cool the motor, and if you have a really tight system, there's no airflow, so it's kind of running.
Well,
without.
again, that isn't the way the shop vacs are designed. They don't put the dirty air through the motor. They have an independent cooling system on them. They have a fan that pulls clean air from the outside over the.
Oh, okay.
So I've seen that complaint before, or that thought before that, you can hear the shop vac wind up, so it's gonna hurt it. It's actually pulling less current, so there's less heat. And in fact, it's got its own external cooling system that's pulling air from the outside, it's not part of the dirty airstream.
Well, thank you.
Yes, sir. Other questions?
Rick,
How did you measure flow?
I'm going to show you here in just my next slide, I think.
Rick,
Before we leave, anything else here?
yeah, I think I might try your system because I have done exactly what you said and collapsed the bowl.
Oh,
My
yeah.
vacuum system. I run a good bowl.
Well, there's no doubt if it's a good bowl and you had a good seal, with a thin wall, it's going to just crush it like a bug.
Yep. So I think I'll try your system.
Okay, well, the 2 points that I want to make here is on this curve before we leave it is, one, the leaks, do the best job you can of containing your leaks, but in the end, it really doesn't matter because the shop vac is a volume machine. It overcomes the volume leaks pretty quickly. And number 2 is dirty filters don't matter. Again, because you're moving such a low flow through the machine at that point in time, there isn't the opportunity for much friction loss, even if the filter is pretty gummed up. Okay, and this is, again, the next couple slides just are more interest than anything else, but this is how I did work up that curve. Again, you might know I'm a frustrated process engineer and spent a lot of my life working on stuff like this. So it gets to be sort of a busman's holiday to start thinking about it. But what this is another wooden fixture that I made that is a venturi. So I'm measuring the pressure drop across this venturi to get the airflow. And the static pressure, I'm just taking off the bottom of the shop vac itself. So in terms of developing the data for my curve there, that's how I did it. Now, in the next shot, this is pretty crude, but we're measuring inches of water column. So here's the static pressure line that goes up here on top of the ladder, back down a pole and into a bucket of water. So you measure the draft or the vacuum here by measuring how far the water it is from the water level to where the meniscus is in the tubing. So that's where I come up with the 47 inches. And then as I let more and more air through the shop vac, why that meniscus drops down and you get more or less and less vacuum. So I was able to measure the flow here and the static pressure here to develop the performance curve on the shop vac system that I.
Got a
Sure.
question for you. I'm a chemical engineer, so I really related to what you have been talking about here. So it brought me back 30 years ago.
Yeah,
But
exactly.
My question is, have you figured out a way to accommodate a natural edge bowl?
Well, I haven't spent a lot of time trying to figure that out, but as far as I know, the only way to do that is with a cup or with a barrel on the end of the spindle. So you can do that, but let me get a couple more pictures into this and you'll recognize the limitations of that.
Okay, thanks.
You betcha. Okay, so anyway, you know, we turned that bowl, no particular problem. So how much vacuum do you really need? Doc Green, I don't know if you've read his book or seen it around, but it's called Fixtures and Chucks for Wood Turning. He says you need at least 50 pounds, and then you've got to be careful. And my own experience says that's right. Now, I'm not going to tell you that I've never lost a bowl off the lathe with a vacuum chuck from a shop vac, because I have. But when I've gone back and looked at, did sort of an analysis on what's going on, 50 pounds seems to be okay. And I've gotten away with it down to 30 pounds of pressure. But that's, just as a rule of thumb, that's where you're at. So how do you calculate what that is? It's the pounds of force that's holding your piece on the lathe. The inches of water column is the one thing that you can read. In my case, it's 47 inches. And it doesn't change much. I mean, it's 47 inches in almost all applications. Then this multiplication in here is the pounds per square inch per inch of water column, and that turns out to be 0.036. So every inch of water column will give you 0.036 pounds per square inch of pressure of vacuum. And then you put that against the square inches, which is just the old formula you learned in 8th grade. The area of the bowl, or the opening of the bowl, is 1/4 pi d squared. So in the case that we just did, it works out to be 0.4 or 47 inches of water times the conversion factor to PSI times the area squared, pi 1/4. Square is the ringer here. Keep that in mind, because here we come up with 120 pounds of force that was holding the bowl on the back or on the faceplate when I did it. And that's plenty. But now I'm going to go to the next slide. Let's go back and look at this machine here for just a minute. I don't know how big this vacuum barrel chuck is, but it's probably 4 inches. Okay, well, if you visualize what's going on, that barrel chuck is on the inside of the bowl. It no longer matters how big the bowl is. It's going to be, your vacuum chamber that's holding it on there is going to be 4 inches in diameter. So it's a whole different principle. But now here you could use this system for a vacuum or for a natural edge bowl with no problem at all. In fact, I've seen that done many times. But again, the diameter here is 4 inches. It doesn't matter how big the bowl is. You're only going to get 4 inches of vacuum chamber on the inside of it. So let's look at that. So this, first of all, let's say the traditional vacuum chuck, instead of 47 inches of water column, let's say it's 250. That's 20 inches of mercury. So you got 250 inches of water column, time the conversion factor. But now you've only got a 4-inch diameter instead of a 9.5. It only produces 112 pounds of force, hold the bowl. So the way we just did it is more powerful, just as powerful as the traditional vacuum chuck. I'll bet you didn't see that one coming, did you?
So, Rick, I have a question. This is a thing that's been discussed before. When we're measuring the area that the air pressure is pushing against, opposite the reduced pressure inside the vacuum chamber, are we looking at the diameter of the rim? Are we looking at the area of surface that is all being pressed?
Well, yeah, the diameter is the first thing you're looking at. So it's in the formula that I'm working at here now. The diameter is of the bowl that I just did was like 9.5 inches. So because that comes up flat against the faceplate, that is the vacuum chamber. The vacuum chamber is 9.5 inches in diameter, which when you run through the formula comes out to be a certain number of square inches. So the same thing on the picture you've got here, where you've got a 4-inch vacuum barrel chuck. The diameter of the vacuum chamber is only 4 inches. So that's the only vacuum you've got.
I was thinking in terms of the volume inside the vacuum chamber. It would change.
No, it doesn't. It's irrelevant. It's the area is the only thing that matters. The area of the air. In other words, on this, I guess I wish I could draw you a picture, but there's only 4 inches of this bowl that's exposed to the air that doesn't have air on the other side of it pushing the other way. When you evacuate this bowl thing, there's a low pressure that's in a circle that's 4 inches in diameter. So the air is pushing on it, but all it can push on is 4 inches of diameter.
Okay.
Now, there's nothing that says you can't use a faceplate on a vacuum chuck like this, and that's when you'll crush your bowl, because the area gets so big so quick as the size of the bowl increases that the pressure just gets unsustainable. But this, because of this kind of a system, has so much power, such a powerful capability in terms of vacuum, you can get away with a 4-inch piece in here and it works just fine. Again, if we looked at this, oh, where did I get to there? Something went wrong. Let me get forward again here. With a 4-inch system, with a 4-inch chuck, it generated just about the same vacuum that we had with the shop vac when we used the whole diameter of the bowl. So again, these aren't things you've got to figure out on every bowl that you take to the lathe. I mean, it's just to try and get an understanding of what's really going on here so you can make your own decision. I mean, where do you stop? Where do you push this through? If you get a pretty small bowl on this vacuum chuck that I just used, it's not going to work. It's going to, you're going to, what I say, chuck and duck. That's what it's going to because it's going to come off the lathe. Let's see, before we go on, is there anything else that people would like to talk about here?
Comment on the picture where you showed the high vac pump.
Yeah.
That system was kind of okay, but it's missing a major component. And between where the rotating vacuum adapter is on the lathe and the head of the pump, there should be a filter. And there isn't any in that illustration. I know that's not your illustration, so but it should be on the side of the rotating adapter rather than, so dust doesn't go through the gauge, protects the gauge and the pump. Without something in there, I've sanded bowls and I actually know the dust will pass right through the wood fibers and into the vacuum system if you don't have a filter in there, and they're cheap enough to put in.
Yeah. That ain't a problem with the shop vac. It loves dust. The other thing, of course, to think about is, when you're chucking in a low vacuum system like we're talking about here, is you got a limited amount of pull that's holding the bowl onto the lathe. As this thing gets longer here, as your bowl gets deeper, you have this leverage effect going on. So it's, you can imagine a hammer here. As you start to push your tool on the back of the tenon to get rid of it here, it's going to try and pull it off. It's a constant battle your vacuum's trying to hold the bowl on, and your tool, you're trying to pry it off. So this gets to be a significant factor if you're low on vacuum, which a shop vac system probably is for sure. So we're kind of down to where I'm wrapping up here, but I made this little table, and again, it's not something you need to use, but if you look at the diameter of the bowl on this side, and here would be the vacuum that the pounds of force that would be forcing the bowl onto the lathe on this side, you can see it's 12, 21, 33. You finally get to 50 with about a 6-inch bowl. But the other factor that you have to think about is if the bowl is very narrow or very shallow, like a plate, it's, you don't have any leverage down here. So it kind of compounds. So you actually get less force going back to peel this thing off with a very narrow plate. So you almost get a credit in terms of pounds. So I put together this table, which is essentially the pounds of actual pressure, and then the leverage that you're looking at with the height of the bowl on this side and the diameter here. In other words, how much leverage do you have to peel it off? And then I came up with kind of an equivalent force And it, as I say, the actual force is here, but when you start prying it off with the lever of your length of your bowl, it either amplifies it or diminishes it greatly. And you can see, I put the red letters in the area where I wouldn't try it. 4-inch bowls too small in any circumstances. But as you start to get, excuse me, yeah, I'd say a 4-inch bowl is too small in any circumstances. But as your bowl starts to get a little bit bigger in diameter, as long as you keep it shallow, it's going to work fine. But when you get up to a ratio of like 2, where the diameter of the bowl is twice as, excuse me, the radius of the bowl is like twice the diameter, then things start to go sideways on you. So as you get further and further away from the faceplate, you get more of this leverage factor in there. But by the time you get up to an 8-inch bowl, you're pretty much home and dry. This is going to work. This shop vac system will work. Now you need to be careful about the tool that you're using. In other words, as you make your cuts, think about every single cut, because if you get a catch, it's going to take it off the lathe at the low numbers. When you get up here to where you're running almost 2,000 pounds with a 16-inch bowl, it's not coming off the lathe. I can tell you that. But in the area here and sort of the fringe area, if you have a catch in this area, why it's going to come off. So just don't get a catch. Simple enough. So anyway, I think that takes us to the end of what I had to share. This is, again, this is a 17-inch bowl, and so I didn't worry too much about it coming off the lathe, and fortunately it didn't. Here's another bowl. This, again, this is a challenge for a vacuum chuck. If you think about it, just intuitively, it's going to tell you you don't want to do this. But I do them all the time. And I do them by putting tape across the back. Again, volume doesn't matter. If you get a little leakage, it doesn't matter. So use the masking tape on the open segment bowls and they turn out just fine. So, any other thoughts or questions?
Hi, Rick. It's Claudia. I just want to thank you for your wonderful presentation. And I guess you spent the entire year plus of COVID developing this wonderful presentation.
Well, thank you. But again, these kinds of presentations are a little outside of what I'm comfortable doing. So I did spend more time than I probably should have on it. But anyway.
Well, it paid off.
I have a quick question too. Do you have to put oil in vacuum pumps? Like if you buy the one-way vacuum pump, do you need to worry about oil in those?
Jim, you're probably better to answer that than I am.
Depends on the kind of pump you bought. If you bought one from Harbor Freight, which is a oil-based pump, they run quieter. They do require vacuum oil, which is basically the same as compressor oil. And they do emit a little bit of a mist. But the one that One-Way sells, which is a gas pump, is a vane pump. So it's sort of like an impeller going around inside, sucking the air out.
Yeah,
So
that's the
when
one I
the gas
got.
pump turns off, it goes to zero vacuum almost instantly. It's also much noisier to use and much more expensive. So the answer is depend on the type of pump that you bought. You may require oil or not. The One-Way's not.
Yeah, I have the One-Way, but boy, it gets so hot, that I usually end up bleeding off some air, so it doesn't use its whole vacuum because I'm afraid it's going to get too hot. But maybe we're off the subject here. I don't know.
No, I think it's entirely on the subject.
Okay,
Again,
good.
the vacuum pump systems, they have so much power that, in one way, they're just tough to beat. But as I say, the shop vac system, if you got an 8-inch bowl or bigger, it'll work just fine.
You can hook up
I could see the bottom of my bowl getting sucked in, and then I open the bleeder valve up, But I just wonder if I was doing something wrong in letting this One-Way pump get really hot, because they are expensive.
You can hook up a pipe to a oil vacuum pump and get it outside in the air, and you won't have anything in your shop.
Yeah.
I think the real trade-off is the fact with the higher CFM that you get out of the shop vac, you don't have to worry about some of the problems of leakages and voids in the bowl edge and things like might cause us a problem with the gas type pump or the oil diffusion. Those
Right.
things require sealing up every little gap and so on, because we can't afford to lose any vacuum at all.
Right.
Yeah.
Thank you.
That's the answer. If you could, if this shop vac system leaks, you do the best job you can and then forget it. That's not going to be your problem.
Okay, that's great. Thanks.
Well, Rick, we've been wanting to hear this for, yes, it's been over a year. And I think it's the solution that many people need for some of the problems, and certainly a much less expensive version. And did you ever consider putting any kind of a bleed system into yours, Rick?
Well, no. Again, I don't know why you really would need that, because the let's see, I don't know, somehow or another the camera switched again.
Never draws enough vacuum to damage the bowl.
Yeah, no, it's not going to ever need that. As I say, it's a more complicated story than I've just told you, for sure. There is actually a case to say that a little bit of air bleed through it increases the efficiency of the shop vac and makes a little bit more vacuum. But it's trivial. It really doesn't matter. But yeah, I think you hit the nail on the head. It doesn't do the things that a real vacuum chuck does, but on the other hand, it's $10 and you're on your way. It's like kissing your baby sister. Okay.
Rick, I enjoyed it a lot. The one thing I didn't enjoy very much is I looked around your shop and it's unusually clean.
Well, I didn't get unusually close to anything for you to really see, Jim. As I say, it's a pretty modest shop compared to the ones that you all have, but actually it does what I want to do, so it's working fine.
Well, it went well, very well, and thank you so much for taking the time to do this. I know that Rick did this presentation under a great deal of duress. I think we had to lean on him a number of times, but it was well worth it. Well worth it. Thank you.
Thank you.
Rick, thank you very much.
Thank you, Rick.
Yeah.
You bet, guys. Looking forward to seeing you soon.
Thank you.
Bye, everyone. Thank you.
Take care.
Thank you,
Bye-bye.
Rick.
Thank you very much.
You're welcome.
Thank you.
Oh, are you going to share that PowerPoint?
I sure can. If you send me an email, I'll send you all. They're actually just photographs. I really didn't do a PowerPoint, but I'll send you all the photographs and stuff that I have.
The reason I say that is my wife's a teacher too, and they were actually thinking that some of the students, particularly in a physics or math class, would love that as a practical math problem. It was very awesome. There's my wife in the background. She's a math teacher. Getting so that was great stuff there.
Not only a math problem, but also how did he figure out how to calculate the inches of water? And so there was the student's process of how am I going to set up to measure this thing without going out and buying something? By the way, I want to add one more point. This session has been recorded, and because it's recorded, Dave Bentley has it, and it will be posted on our webpage at some point. And so your wife can get access to it just as soon as David has it posted.
Excellent. Thank you very much.
Hey, Rick, this is Dave. If you send me those forms or the things that you were showing, I can put them in just below your presentation so that anybody in the club can access it. So
Sure.
If you do, I can put it in just a file that they can click on a link and it'll open up for them and they can download it on their own.
Okay, I'll be happy to do that.
Rick, how did you calibrate your Orifice?
Well, I didn't. I just, it's again, it's a theoretical calculation, you know, as the velocity increases through a venturi like that, it, you know, it's a Bernoulli principle. So it just gives up static pressure. And the formulas are pretty well defined for that, as well as the coefficients that people have been making them for years. So I just use the theoretical calculation.
So it's a sharp edged orifice?
No, it's a venturi, you know, where you've got like a 30-degree entrance into a smaller tube, and then it evacuates at, you know, a shallower angle.
Thank you.
You bet. Okay. And we're down to 9, so I guess we're done.
Go get a drink.
Yeah, that's it. I will. Thank you. Okay. Talk to you all soon. Bye-bye.
Okay.